Hi there, and welcome back to the third part of my tutorial about how to deploy large language models application. And today we're going to cover the aspect of how we are going to deploy to the external world our application once it's been developed and tested on the local host. First of all, just as a reminder, this is how our architecture looks like. So we have some kind of front end developed easily by Chainlit, which is using Haystack as a natural language processing orchestration, and Weaviate as a vector database, and then we're using Mistral.AI as a language model. Now we have two possibilities to, once we are running these things on a local host going to the outside world. One is that we set up a private machine, but this requires some kind of tunneling settings, or we use some quick and dirty solution like Grok, where you need to do some kind of porting from your machine to an external IP that they offer you. Looks like something like this. So it's simply pointing an external address, for example this one, to your local host, and it's going to the outside. And this is good for some kind of initial testing, but as I was telling you, it's not strongly recommended to use for commercial application. Also because you still need to think about the load and balance of users on these machines. Like, it's pointing directly to your machine. An alternative solution, which is what we are going to cover with this video, is instead to deploy on a Amazon Web Service, because in this way you of course might going to pay some fees, but everything will be secured on an Amazon Web Service in terms of security, and also will be scalable, because you can implement load and balance scaling. So depending how many people are going to connect to the IP, it's going to manage the load. As a starter thing, is the best way is that we Dockerize our solution. And for example, we need to get first of all a Docker file like this one, where we have to point, for example, that it's going to read the requirements on our specific file requirements, the .txt, and what is the name of the Python function that is going to be launched by Chainlit. Because remember that, again, this thing is not calling directly Python script, it's more like calling first Chainlit. And so let's start from there. So let's start building our Docker container locally. So first of all, let's build our container from what we have in our local folder where we have our application. So this might take some, oh no, it was fast. And now let's, if I want, I can test it still locally to see if this build thing is running properly, at least locally. And it seems so. This is still my application. Now what we have to do is to log into the Amazon Web Server page. So you need to have at least one root account and one IAM account. And so essentially we need to create three things encapsulated. So first we need a repository, then we need a task, and then we need a service. And the three things are connected together. So let's first go to if you go in the dashboard on top and you write ECR, you can enter Elastic Container Registry. And you click Create. And here we can create, for example, something like Chainlit demo. Maybe I call it Chainlit demo. And mutable, I'll leave it mutable. Encryption is fine. So just click Create. Once the repository has been created, we click on it and we see that there is no image associated. So what we have to do, we have to follow the push command, which is essentially you have to copy and paste this. And if your login has been properly configured before, you should just simply copy and paste these things and run it. So I copy this here. And the login succeeds. Perfect. Now it's asking me to build the image that we have already done it, but just to follow be consistent with the script, with the instruction, I do it once again. And you see it was faster. And now I'm supposed to tag this image. And now I'm supposed to push the image from my local machine to the Amazon web server. So let's see what we have. If I refresh, I have an image here. I need the URI of the image because I'm going to use it for the next steps. To launch the service in the task, I type in on top of this dashboard ECS, and we go here, and now we're supposed to create a new cluster. So cluster, I call it the Chainlit app demo cluster. Infrastructure, I can leave this one, and the rest I will leave it as it is. So I create it. So now I'm here in task definition, and I proceed task definition. Chainlit demo app task definition. Infrastructure, normal Linux, 1 CPU, 3 gigs. Container, we have to specify our container. And we can finally paste the address we copied before. And this is important now. I need to also add the port mapping 8080, because this is how I was using it in my localhost. And for the rest, looks fine. And we to define a new service. So it's correct, existing cluster, capacity providing strategy. The rest looks fine. And here we relate to the task we have just defined. And we call it Chainlit demo service. Replica is fine, decide task only one, go. Okay, the service is running. So now, just to be sure, it's good if we go and check that the port forward within the image is functioning properly. So I go to cluster, double check the service, and in networking you will find security groups. And inside inbound rules, we should be able to click edit inbound rules. It's already there, so it's supposed to work. So we don't need to do anything, but if this rule was not there, we're supposed to add it. Now we just have to figure out where is the public IP of our service. And for this, we go to cluster, our cluster service, and under task, where is it? Tasks, and this is my public IP. So if I go here, I should be able to see my large language model application. Ta-da! And in fact, this is our chatbot. Now, this is of course not fantastic because it's just an IP, and also it's still working as appearing to the user as HTTP. So what we need to do is probably to buy a domain and add a certificate to appear as a HTTPS, and also to appear as a normal name, like more human name, like mylanguagemodel.com. This was not much coding, but it was more like connecting our language model application and deploy it on a Amazon Web Service, but it's like still an important aspect if you want to put on the real world your application.